Hey everyone, Brian here, AstroLift 2000, and I just read an article today that the new Comet Lemon will be visible tonight in the Northern Hemisphere. So I'm going to give it a shot to see if I can get some imaging on it with the Edge HD. But I wanted to show you guys how to import comets into Stellarium if you weren't sure how to do that. It's pretty simple. Once you have Stellarium open, you click on the configuration window right here, plugins. Make sure you want to have Solar System Editor highlighted over here, and then you click Configure. You want to make sure the Solar System tab is checked up here, and then you want to come down and click Import Orbital Elements in MPC format. You want to make sure that you switch this to comets. It defaults to asteroids. And for the bookmark, you want to select this one right here. It says comets at the end. Careful, there are two that say comets. You want to select the first one. Then you click Import Orbital Elements. And now this is going to give you the list. I mean, you can check them all if you want, or if you want to find the one in particular, here it is right here, Comet for tonight that I'm going after. So you would simply check it, click Add Objects, and that's it. Once that's done, we will close all these windows. Now we're going to come over here to the search window. And I searched it previously, but you would put the name in and then bam, there's the name of the comet right there. Let's do some planning and see where this is. So at dusk, the comet will be directly overhead, which is great. Oh, and then we'll see back out a little bit and let's see where this goes throughout the night. So it looks like I'll be able to maybe get 3 hours or so of time on this. I mean, you don't need that much time for a comet, but it gives me a nice window. So let's get outside and see how it looks when I'm imaging this. I'm not sure of the framing, if the Edge HD is going to be too deep, or maybe I need something a little bit, but I know this from previous images that it was shot with a 14-inch Edge, or a 14-inch SCT telescope, and it was pretty small on there. So I'm going to try it with the Edge 8-inch and see how it looks. All right, so I'll be back, everyone. Thanks.
Brian here, and I was able to lock onto the Comet. I got a pretty good field of view with the Edge and with the Explore Scientific. They're both collecting images on it right now. The Explore Scientific right over there. So let me just jump into the tablet and show you guys what I got with the Comet so far. It's pretty cool. Okay, and lock on to the Comet and collect 120-second long exposure. You can see here how much the Comet had trailed. It was very easy to go. All you do is punch in the coordinates right next to where it says target and go. You click right here. You put in the coordinates that I extracted from Stellarium right here, and then you click go, and the Comet popped right up. So some people guide on the head of the comet, or some people guide on the stars. I'm gonna guide on the stars. I'm gonna set up my auto run, continue here. I got 11 images. I'm gonna keep going with that, and then I'm gonna bring this back into PixInsight, and I'll show you guys how to stack the comet data.
A pretty successful night of capturing the comet. And you saw in the beginning of the video, I actually captured it with 60-second long exposures. That ended up being too long. Again, this is only my second time capturing a comet. I'm no expert, but I did get one successful image. And so I figured I'd share the process with you guys. So 60 seconds. Yeah, it was too long. And whatever your single exposure looks like of the comet, the head, that's what it's going to stack like, just like regular astrophotography images. So I just didn't realize that. So the 60 seconds was too long. So I backed it down to 30 seconds. And for the ED102, a 30-second exposure was fine. The comet core was nice and round. However, for the Edge at 2000 millimeter plus focal length, 30 seconds was still too long. This comet was moving really fast. So I had to cut that back down to 15-second exposures, and the comet head looked nice and round. But the Edge with the 2600 MC one-shot color didn't pick up any tail on the comet, whereas the mono camera did. So I didn't process the one-shot color data any further, or yet, maybe I will. I just processed the mono data, but I'll show you guys both one-shot color and mono. There's really no difference. There's one extra step with the mono, so don't be scared to shoot a comet with a mono camera. Okay, so let's jump into PixInsight. And we'll get right to it. Here's the completed image of the comet. I was pretty happy about this. The nice green big head looks awesome. The stars came out really nice. I was able to get the background. The hardest part about processing the comets is the backgrounds for sure, because you have to remove the stars from the comet image, which are trailed, and then use them with the stars from the image of just the stars where the stars aren't trailed, you know. But I'll show you as we go in here. But anyway, here's the completed and final image. You can see we picked up the tail here, which is super rad. So I'll just move this over to the side. Okay, so how do we do this? Well, it's not that much different than regular images or image processing. So stack all your images, your comet images, just like you normally would for processing images. And if you shot it in mono, and when you're shooting the comet, it doesn't matter what order LRGB that you shoot them in. You just want to start one where you start, just try to run the comet in one nice sequential process, no stops in between. Just makes processing easier. And if you blink the images, it will give you a nice smooth movie for the images. So I'll show you that too. Okay, so again, process all the images like you normally would with weighted batch pre-processing. We're going to want to go for is the master frames, and we're going to look for the master lights. And you're going to want if you shot it with a one-shot color, you just have one file here, which you'll grab. And this is going to be for your stars. With mono, you want to use the R, G, and B. We don't need the L. Here's the master lights, R, G, and B. And I named them R, S for red stars, GS, green stars, etc. So here's the three frames, the three master light frames right here. And what you'll want to do is I just use channel combination and just put the names in real quick, BS, and then execute. And then you're going to we're going to have this image here, which is now a color image. And you could see the different exposures that I shot the comet. You can see when I shot the red, the green, the blue, red, and then green again. So that's pretty cool. This image is just for our stars. So let's get rid of channel combination. You would then process this image just like a regular deep space astro image. You want to stretch it, do your color calibration, blur X, and you don't really have to denoise. But once you process it far enough along, you want to then just remove the stars from that image, because that's all we're going to want. So that's all we have left here is the stars. Okay, so I can minimize these. That takes care of the stars. Okay, so once you have your stars all processed and ready to go, we want to get into the real comet processing. So you want to go to process, all processes, and comet alignment, which is right here. Okay, so let's just add the files. And if you shot it with a one-shot color, you just add all your frames. And it's no different if you also shot it with a mono camera. You dump all your frames in here. We are looking for the registered frames. And if you shot it with a mono, you're gonna have to go in and grab each one of these. If it was a one-shot color, you're just gonna have one folder in here. You just grab them all. So let me just grab all these files real quick, show you guys. Okay, all the files are now loaded in from the mono LRGB. And all you have to do, first step is you come up to the first frame, you double click, move this out of the way. You want to stretch the image, find the head of the comet, and just double click on it. Now you're telling it where the comet's starting and ending. That's all you're doing here. So then you come down to the last frame, same thing, you double click, stretch it. Click on the head of the comet. You want to specify your output directory. You don't have to worry about your subtraction image because we're going to use the stars from the registered image. So you just specify where you want it to place all the comet aligned folders, images, and you click the circle here, and that's going to execute. Show you what we get. So comet aligned, it's going to add the little CA to the end of the image right here. So once all the images are comet aligned, you then want to remove all the stars. And if you have star exterminator, it's going to make your life much easier because you can batch process the star removal. So you just click right here, batch process, and you tell it where you want to put the starless files and the star folders files. We don't need the star files because, again, we're going to use the stars from the registered image. Then you select the images that you want to remove the stars from and execute. Pretty simple. Takes a little bit to run right here. Now, at this point, these images have been beat up. They've been calibrated, registered, aligned, stacked through weighted batch pre-processing. Then we ran it through Comet Align, which is now the CA that you see right here, stands for Comet Align. And we also ran the images through Star Exterminator to remove the stars. Honestly, I tried it both ways, guys. Star Exterminator first and then Comet Align. It works fine both ways. So don't get hung up on those two steps there. Either way is fine. Okay, so now we have all the starless images, Comet Aligned. What do we do now? I'll show you. Move this over here. We're going to go process, all processes. And we're going to come to image integration right here. Now, if you shot with a one-shot color, this is cake. You just click add files and you want to come up and add the comet aligned and starless images, starless and comet aligned. And if you shot it with a one-shot color, this is no problem. You just grab all the frames and dump them in to image integration. If you shot it with a mono camera, you have to combine each channel, and this is the one extra step that you would have to do with the mono camera. So it's not really that big of a deal. So you just select all your Bs, all your Gs, Ls, and Rs, and open. Okay. And if it was if it was a one-shot color, you would just grab all the frames. Okay, so this is for the B channel. And again, if you shot this with mono, you want to run image integration through each one of the channels, L, R, G, and B. And here are all our integrated images right over here, L, R, G, B. As soon as you get them out of image integration, I'll show you. Here we go. We're going to run image integration on the Bs. All right. Here's what you get out of image integration. The rejection, which you don't need, just close that. Okay. And here's our B. Doesn't tell you that. I wish it did. Just says integration. So you want to make sure you immediately rename it to B so you don't have a bunch of images all called integration and you don't know which is which I've done before since I already have a B here. So that's how you run image integration on each one of the channels. So we have R, G, and B. This is just an auto stretch on them. No processing has been done to these since I brought them out of image integration. So then I'll just do channel combination on R, G, and B, and combine those channels. And here is what we get. Yes, here's the RGB image. You can see the comet, the core stacked very nicely. And you could see a faint part of the trail right here. So at this point, you could process this image just like you would a regular image. You can run your DBE, denoise, stretch it. Let me just close this. And then you're going to have the most important part of this, the luminance, if you shot it mono. And this was the big difference between shooting it with a one-shot color and the mono. You can see how I picked up this nice trail here. But you also have the star trails, the residuals left over from the stacking and from the star removal. So this is the biggest hurdle in processing comets, is trying to clean up this background. And it's not very hard. Through various masks, clone stamping, you can clean a lot of this up. And when you add this luminance to the RGB image and then add the stars over it, you'll see how much the image really cleans up. So you don't get really freaked out about how bad the background looks. So let's close the luminance. This next image is going to be, this is the RGB combined. We already saw that. So here's the RGB with the luminance. So let me back this up. This is just the RGB image. And what we're going to want to do is LRGB channel combination. Take your luminance and you want to just overlay it onto the RGB image, and that will clean up. You'll see a lot of the background. Okay, see what I'm saying? It's very impressive, this adding luminance to the image, how much it cleans it up. Noise, and now we can really see that nice trail coming through here. Now, again, you could process this even further, clean the background up as much as you want. And we're getting towards the end here. Hopefully this isn't too brief. And so now you want to take your stars and your RGB with your luminance. And you want to open up Pixel Math and combine the two. And here's what you get. Then you got a little area green up here from the comet, but I'll just clone stamp that out. But you can see how adding the stars, oops, kind of hides a lot of the nasty stuff going on in the background. You can see some here and here, but that's okay. We can go back into this image and clone stamp those out and clean them up. Okay, and then this is how I image geometry to rotate the image if you wish, like I did. And I didn't crop anything yet either. So the last step is I would then crop it to cut all this frames that were left over from stacking up here to give me my final image. Let me just close these. And there's my final image. You can hit this with some local histogram equalization, play with the curves. Okay, I just want to show you quickly how to blink the images. So you want to go to process, all process, and blink. What blink is it lets you skim through your images quickly to catch the ones that have clouds or planes or star trails, things like that. You can also make little MP4s or AVI movies out of a bunch of still images, and it works great on comets. So let me show you guys. See, again, I showed you how to open blink, and whether you shot this with a mono camera or a one-shot color, you load all your registered frames into here from weighted batch pre-processing. It's going to open up this screen here, which is your image. And then you click the little play button. You can set how long it's going to show you between the frames. And you can see the comet moving. So cool. You can also make this into a little movie. You click this little button right here. And this was a little bit setup for me. I will give you guys the quick version of it. You have to go online and download this program right here, ffmpeg.exe. I just Googled it. I downloaded one that I found, and I dumped this program, the .exe, into the bin folder for PixInsight. Maybe yours came set up that way. I saw some people online that it works for them, no problem. That wasn't the case for me. So that was what I had to do to get this to work. And then right here, depending on how many frames you shot, this is the frame rate. It's set here at 25. If you only have a few frames, maybe you want to set this at 5. If you have a bunch of frames, maybe you want to set this number higher, but you can play with it and see what it ends up giving you. And then we click this button right here and run. Oh, forgot to specify where it's going to save all these to. So we'll just save them to here and click run. Okay, it finished. And then here's where it dumps all the files. It creates little PNGs and then stitches them together to make a movie. Let's see what we get. You can see how the frame rate is definitely set way too high on this. So let's say we set this down to 15. You just click rerun, and then bam, it updates the AVI that quickly. There we go. You can see it was moving much slower. So that's how you make those quick little AVI or little MP4s that you keep seeing online. Just wanted to show you that real quick. Hopefully you guys were able to catch this comet, and let's see what you guys got. All right. Thanks everyone for watching. Brian, Astrolibs 2000.